So this workshop is presented by Lingling Xu, Bingjie Xu, Shalini, Pochineni, and Shi Li, who are all data scientists at Google. They will present the second workshop in their series, and it is entitled Open Source Propensity Model Package, Accelerating Data-Driven Decisions. Now, like I mentioned, this is the second installment in their series, so if you would like to check out the first version of this video, you can go onto YouTube.
Hello, everyone. Welcome to the second workshop on Open Source Propensity Model Package. We introduced the package and its business application in the previous week's workshop. Today's topic is from model building to model activation. I'm Lingling. I'm facilitating this workshop series together with my colleague Bingjie, Xu, Shalini, and Rukshan. We are all marketing data scientists at Google, coming from 4 different markets: Greater China, India, Southeast Asia, Australia, New Zealand. A quick self-introduction. I worked in the data analytics area for 10 years across healthcare, consumer goods, and the technology industry. Now at Google, I help Google's largest clients to improve marketing effectiveness by building quantitative models. Shi, over to you for a quick intro.
Thanks, Lingling. Hello, my name is Shi Li. I'm a data scientist at Google, helping large clients to measure and optimize marketing return on investment, also answering key business questions by building predictive models. I was working as an engineer and consultant with experience in machine learning and marketing analytics.
Thanks, Shi. In the previous workshop, we introduced the propensity model concepts and workflow, provided an overview of the propensity model package compass and the dataset used. We also went through the first phase of the modeling, data preparation. I'll do a quick recap here. For full details, please refer to the link above. What is propensity modeling? It helps to identify the likelihood of someone performing a certain action in the future. Propensity model is widely applicable. In business and marketing context, the future action can be a customer performing a purchase, subscription, or churn. In finance, the future action can be a customer defaulting on a credit card loan. In healthcare, the future action can be a patient developing certain disease. The Compass package focuses on business and marketing use case. The propensity model flow looks like a typical data science modeling flow. What's unique is that it involves defining 2 time periods. Output of the model is the likelihood of the user performing a certain action in a well-defined time period in the future. We achieve this outcome by learning from past behaviors from a well-defined time period in the past. Propensity modeling accelerates data-driven decisions and actionable insights. The estimated propensity score can help the business to make data-driven decisions, such as improving marketing campaign, in order to optimize key business objectives, like increasing conversions or reducing churn. We will talk about activation phase in this workshop, which illustrates this in more details. In addition, insights extracted from the model can help the business to understand key drivers of the target event of interest. Some of these insights can lead the business to take useful actions. Our open source package Compass helps build and activate an end-to-end propensity solution to drive a marketing use case. This is the GitHub link for you to view the package and the notebook. To run the package, you need to access Google Cloud Platform and get your data available as a BigQuery table. The datasets can be Google Analytics or CRM data. Notebooks in the package use Google Analytics data for table and feature references. The package includes 10 notebooks, enabling the process of data preparation, modeling, and activation. Workshop 1 introduced data preparation steps. Exploratory data analysis and validation help us to assess the feasibility of building a model. Data preparation steps prepare a rich ML dataset by extracting a series of data snapshot dates. Data preprocessing split the dataset into training, validation, and test datasets. Now we are ready for the next steps, modeling and activation. Modeling phase include ML training, ML evaluation, and insights generation. Activation phase is to apply the model predictions to design, activate, and measure Google Media campaigns so as to optimize business objectives. She will help you to understand the modeling phase.
Ling. Now let's talk about the model training in propensity modeling. In the last session, my colleagues Shalini and Bingjie have introduced how to use historical data to create a model input dataset, combining features and labels. Then split the dataset into development and out-of-time test dataset. Today, I will start from the development dataset shown in this diagram to explain the details about propensity model training. Next slide, please. Before model training, the development dataset is divided into 3 parts: training, validation, and in-time testing dataset, containing around 80%, 10%, and 10% of the whole instances, respectively. The data partition ensures that these 3 datasets contain a mutually exclusive random subset of the total instances. The training and validation dataset will be used for hyperparameter tuning and model selection. The in-time test dataset will be used for reporting the performance metrics. And the final model will be trained on the whole model development dataset. As introduced in last session, in the machine learning data preparation notebook, we have discussed how to create feature dataset and target labels. We suggest first generating features and labels using model development dataset, then split it into training, validation, and testing partitions. Next slide, please. Creating a machine learning model generally can be a complicated, iterative, and long process due to the algorithm selection and hyperparameter tuning steps. In this notebook, we are using AutoML, which enables developers to train high-quality classification models and effortlessly deploy the optimized models in production. AutoML is part of Vertex AI, which is a unified platform to build an entire machine learning workflow on Google Cloud. To further simplify the process and let users easily complete the model training in Python notebook, here we use the BigQuery machine learning tool with AutoML models option, which has 2 advantages. First, it uses AutoML to automatically handle feature pre-processing and hyperparameter tuning for multiple algorithms in parallel to train the best model with respect to a given performance metric, such as AUC, ROC. Secondly, BQML enables the creation and execution of model generation in BigQuery using standard SQL queries. Next slide, please. This notebook demonstrates 5 main steps in the model training process. After installing and importing the required modules, you can set the parameters such as the BigQuery table ID and the dataset ID of the training data. Then, in the model type configuration, BQML supports the following types of models: binary logistic regression, AutoML tables for classification, boosted tree for creating XGBoost-based classification, and DNN for creating TensorFlow-based deep neural network models. Besides model type, another important parameter is the optimization objective. Here in the example, we choose to optimize the maximum AUC ROC. You can use other optimization objective function like minimize log loss or maximize AUC PR. After training the model, we can use the validation dataset to measure the model performance by simply calling ml.evaluate function. The output of evaluate function includes normal model performance metrics like precision, accuracy, recall, and so on. Next slide, please. Although the BQML offers easy function to check the model performance, the evaluate output does not tell the source of the business problem. That's why we created another model evaluation and insight generation notebook. It is important to diagnose a model thoroughly to make sure it's reasonable to generate business insight. The main impact of this notebook is that we can generate business insight about feature and model before actually deploying a model in production use. Secondly, it helps to detect the label leakage if one or more features directly or indirectly present the targets in the dataset. In that case, the model performance metrics look near perfect, but it makes the model useless for practical application. Last but not least, model training is an iterative process. We can build better models based on the insight learned from the existing model diagnostics. Next, I will introduce each available function in the notebook. Next slide, please. From one simple demand, we can get an overview of model performance. And if you have rich experience in building classification models, you can quickly debug from the visualization plots in the right-hand side, deciding whether this model is useful or not. It also visualizes the model health, telling how good the model is by visualizing the distribution of predicted probabilities for both positive and negative target labels. Next slide, please. To further evaluate the model performance, we also create decile plots and cumulative decile plots to diagnose from bucket levels. It does the following. Firstly, it sorts predicted probabilities in the descending order, then divides the instances into 10 equal-sized bins, such that the first bin has instances with the highest probabilities, and so on. Secondly, it calculates the precision uplift, and the coverage for each bin. The precision uplift means the precision of the bin divided by the proportion of positive instances in the dataset, indicating the precision of selecting a random sample of the size of the bin. These plots can give an understanding of model performance for these different bins of probability predictions. Generally, we would expect to see a monotonically decreasing trend of these metrics going from top bin to the bottom bin. If we see some different patterns from this plot, it would create some doubts of the quality of the model, leading to further investigations. Next slide, please. Besides the model itself, we also want to take a deep look at the user behavior from the feature exploration plots. The question we want to answer here are like, what are the important user behaviors or features from the model? How does each important feature correlate with each other and with the target? In the example here, numeric feature plots can tell us what are the features that are highly correlated with the target and whether the features have positive or negative correlation with the target. On the right-hand side, categorical feature plots. For each categorical feature, we plot the distribution of categorical values within each bin to observe the relationship between the predictions. Next slide, please. Here is an example of one suspicious numeric feature that we detect through insight generation plots. The x-axis represents the predictive probability bins, ranking the highest probability group to lowest from small to large bin numbers. The y-axis represents the average of numeric feature in each bin. From the plots, we can easily find that in the first bin, which is also a high probability bin, it has very different value to the rest of the instances. This feature could potentially leak certain information about the target label, and it suggests that we need to further investigate to make sure this is not due to data collection or processing issues. That's the end of Model Evaluation Notebook, and I'll hand it over to Lingling for the next part.
Thanks, Xi. Once you have a satisfactory propensity model, you can activate the model to optimize key business outcome. In this example, increasing conversions, more purchased at the website. To do that, you design and activate a marketing campaign, and to target the users have higher probability to purchase instead of a random set of users. To do that, you want to understand who to target, how many to target, and make sure you have a proper control group. Notebook 6 to 9 helps you to do that. After running the campaign, you can use Notebook 10 to do post-campaign analysis to understand, is the treatment group better than the control group? Notebook 6 media experiment design is to design a statistically sound media experiment for the campaign. Input of the notebook is an already scored test data set, which we use in the model evaluation step. This data set contains predicted probability scores and the true label. The notebook calculates the sample size given a specific design. Sample size depends on a few things: baseline performance, in this case, the current conversion rate; effect size, in this case, the expected uplift from the campaign; statistical confidence, and power. These are input parameters for the notebook. Output of the notebook is an pandas data frame for the sample size for each combination of these input parameters. There are two main ways to use the output of a propensity model and to design for the campaign. One is to define different audience groups based on the predicted probabilities, such as high, medium, low group, and then to test the same or different marketing strategies within the group. This strategy is useful for you to understand how the different groups respond to the campaign. By comparing the controls from the different groups, you can also understand the effect of propensity model prediction. To calculate sample size for the propensity groups, in the notebook, we call this function chi-squared sample size for bins. The input parameters are the labels, the predicted propensity score, number of bins, uplift percentage, power, and confidence level. When the number of bins is 3, the users are grouped into 3 groups: high, medium, and low. And then within each group, the current conversion rate can be calculated. The output is the required sample size for each group and for each combination of the input parameters. With this minimum sample size and the available sample, you can decide which specific setting you want to select for the actual campaign. And then you can use the setting to set both the test and control cohort for the experiment. The other way to design the campaign is to optimize marketing for top propensity group. We target the top N% of users having the highest predicted probability. Let's call this selected group. This strategy is useful for you to understand how the selected group respond to the marketing campaign. In addition, if you randomly select N% of users, let's call this a random group, you can also understand how the random group respond to the marketing campaign. In addition, if you compare the controls from both the selected and random group, you can understand the effect of propensity model prediction. To calculate the sample size for such design, in the notebook, we call this function chi-square sample size for cumulative gains. The input parameters are the same as the previous approach, but the calculations are based on cumulative gains. When the number of beans is 10, the first bean gives you the top 10% of users based on the propensity scores. Second bean gives you the top 20% of the users, and the 10th bean gives you the top 100% of the users, which is all the users. Similarly, current conversion rate for each group can be calculated. And the output is the required sample size for each group and for each combination of the parameters. And then based on the required sample size and available samples, you can decide which setting to select for the actual campaign. And then to use the required sample size to set for both the test and control cohort for the campaign. We've done enough solid preparation based on the known data. Here comes live customers. Recall that we want to target them for a marketing campaign based on their predicted probability to purchase. These notebooks make predictions about the live customers. The input is the pre-trained model stored in the BigQuery and the raw data to be predicted. In a notebook, there are two steps. Step 1 takes the data as dataset as input, do some pre-processing, and to create a scoring dataset. The pre-processing is about extracting instance and features. Make sure to use the same parameters used in the training data creation. Step 2 is to score the created dataset from step 1 using the developed model and to upload the prediction into a table in BigQuery. Now you can generate test and control audience group for marketing campaign based on two things. The score data generated from the previous step and the sample size estimated in the media experiment design step. The output is the test and control audience. For the notebook, let me highlight the parameter setting. This points to the score dataset, which includes all the users. Audience group is the number of propensity groups you want to divide the scored users into. Minimum sample size is the minimum number of samples to draw from each group. In this example, we are drawing different size of the samples formed from the different groups. Let's further look at the input and output of the data to have a better intuition. Step 1, read the prediction data set. This data set contains the predicted propensity score for each user and each snapshot date. Then it creates a test and control group for each audience group. Here's a summary of the created groups. This is the number of samples from each group for test and control. When the user is not sampled, it's shown as NA. The last step is to write the audience table into a BigQuery table. As you can see, the last two columns is about the audience group and the test versus control group. Now, you can upload the created propensity audience into Google Marketing Platform. You use this Notebook 9 to do this automatically. It uses a package called Google Marketing Platform and Google Ads Connector. The test propensity audience will be uploaded to the Google Ads system and then be activated as either acquisition or remarketing campaign in the selected Google Ads product, such as search, display, or YouTube. The control group will remain in the BigQuery to be used at the analysis stage. Please note that to run this notebook, you need customer advertising account with Google. After running the campaign for a desired time period, you can check the results, look at the number of conversions from test and control group, and then use the Notebook 10 to analyze whether the two groups are significantly different. In the notebook, you simply set the parameters, including test group size, test group conversion, control group size, and control group conversions. Then you run a chi-square test to get the p-value, which tells whether the two groups are statistically different. If you want to run multiple comparisons, you can set the parameters differently and then run the test again. After observing some good results from the initial setup, you may want to continuously run the strategy to optimize. You might then want to productionalize the process. To facilitate this, the Compass team is developing an automated media activation pipeline for batch scoring, audience generation, and audience uploading. This will be the upcoming Notebook 11. Please stay tuned. Now we've completed introducing the Compass package. What are the key takeaways?
We have concluded the key takeaways from today's session as following. Firstly, we'd like to emphasize the importance of problem statements using the propensity package. Propensity model can help identify the likelihood of someone performing a certain action in the future. So it's critical to identify in certain business cases which business problem is potentially a propensity problem and what would be the target action to predict likelihood. Secondly, the propensity package is flexible for use. There are 10 notebooks we've covered in the session, while you can run any individual notebook in the process by identifying the input, output, and configurations. Also, within each notebook, there is flexibility for parameter tuning, and you can modify certain commands to fit your best use. Thirdly, the process is iterative. All notebooks are linked by data input and output. You can always go back to the previous notebook if you find any issues or places to optimize in the current running notebook. Last but not least, the data and the model diagnosis is very important. It is essential to diagnose a model thoroughly to make sure it's reasonable and to generate new business insight for the real-world application. Since the model is iterative, we can always build better models based on the insight learned from the existing model diagnostics. That's the end for today's session.
Thank you very much for attending this session. Hope this is helpful.